the first software bug, or more or less a hardware bug, at least the first one that's been documented. And I imagine the person that put this bug there had two things in mind. First of all, it's like a trophy. Hey, look what I found, this bug. But also as sort of a warning. So if you have an issue in that system in the future, look at this bug. And by the way, I think this was the last time that you could really say, is it a bug or a feature? No, it's a bug. So Lila yesterday introduced you to the German word eierlegende Wollmilchsau. And I'm going to introduce you to another German word, which you may already know, which is schadenfreude. So the experience of pleasure, joy, or self-satisfaction that comes from learning or witnessing the trouble, failures, pain, or humiliation of others. And let's be honest, that's fun, right? Why do we look at videos on Instagram or on TikTok of a wedding couple falling into a pool? Why do we look at pictures of cats jumping at glass windows or something like that? Because it's fun. So why do we look at bugs? Why do I look at bugs? Why I hope you're looking at bugs? Because it's a schadenfreude. It's just funny looking at them. And we're going to have a lot of that today. But what I also want you to take away is that we should get better at avoiding bugs, because bugs are expensive. They're really, really expensive. I try to find a good number of how expensive they actually are. That's not as easy as you might think, but this is one number that I found, which is 1.5 trillion US dollars in the US alone. So if the number is right or is it wrong, I don't know, I don't care. I think we can agree bugs are expensive. And the more we try to avoid this and we accomplish to avoid them, the better for our teams. So let's start. Let's look at I've called them all stars of software bugs. And let's look at what they were and what they did. And the first one that I brought is the Mars Climate Orbiter. So I'm a big space nerd, and looking at this stuff, it's rocket science, right? So the Mars Climate Orbiter was, as the name suggests, a probe that has been sent to Mars, and that should study the climate of Mars. But it didn't work. So the first part was great, right? This big rocket launch, everyone was celebrating, yeah. Then it takes some time to get to Mars. And when the probe arrived at Mars, well, nothing happened. The ground lost contact with the probe. And well, speaking about expensive bugs, that was quite expensive. The probe was a little over 300 million US dollars. Plus, imagine there were series of scientists who wanted to write their PhD thesis about the data that was collected by that probe. All of these people didn't get to write their thesis, or they had to change the topic. So it just impacted a lot of people, not about with the money, but with everything else as well. And what happened was that the probe was designed to enter Mars orbit at around 150 kilometers, but the actual orbit that it took was more like 57 kilometers. So they were not really sure if the probe actually bounced off the atmosphere of Mars or if it crashed on Mars, but the result for the people was the same: it didn't work. And then they found out, so what actually happened? Why did the probe not get into orbit and give us the data that we wanted? So they found out there were different teams or different subsystems. You may know that. So one of the teams or the subsystems was Lockheed Martin, and they were the ones who were creating the hardware. So they built the probe, and they built all of the software within the probe that was sending data, collecting data, and transmitting that. And then there was the second team at NASA, at JPL. They were the ground station. They were receiving the data, building, I don't know, big Excel sheets with what do we have here, and then do the evaluation of what they had. So Lockheed Martin, Team 1, NASA, JPL, Team 2. Lockheed Martin, American company, yeah, America first. What they did was they used imperial units. NASA, scientific community, right? And the scientific community, they have accepted, okay, we have SI units. So yeah, this is what happened. So the Lockheed Martin team who were creating the probe, they actually sent the force, the acceleration force, in pounds of force. And NASA thought that, oh, well, they're sending us newtons. So I think it was a factor of roughly 4.5. So that's what happened. The ground thought, this is this value, but it actually was another one. But the funny thing here is that they realized that. So the ground team at NASA JPL, a couple of days before the probe was expected to enter Mars orbit, they got the data and they saw, this doesn't look right. And they were clever people, so they pretty quickly found out, oh, this is what happens. They are sending us the values in empirical system, but we are expecting them in SI. And they went to their managers and said, hey, we have a problem. We also know how to fix this. And the managers said, no, you can't do that. This is not the proper channel. Right? I'm a German, I can sympathize with them. They didn't fill out the paperwork. So, and they told them that, no, you have to fill out the paperwork and you have to get approval from this and that and so on. And the engineer said, well, we don't have the time. You know, there is just this small window, so we have to get this done by, I don't know, tomorrow in a couple of days. No, please go to the former channels. So, this did not work out, so it crashed. And what can we take away from that? So, looking at this, I mean, these are rocket scientists. I mean, this is NASA. For me, if they can make such a huge mistake from such a tiny, small detail, then we can do that as well. But then you say, oh, well, we don't have the problem between empirical units and SI units. Well, maybe you don't. But has anyone seen code like this? In get total amount, what is that? Is it euros? Is it pounds? Is it US dollars? Is it Bitcoin? I don't know. So you think they're giving you euros, but they are actually giving you pounds or cents or whatever. And then you say, oh, yeah, well, we can write documentation. So the problem is gone. Well, if you look at the code, maybe yes, but then again, who reads documentation? No one. So yeah, but then we can have that in the method. Yeah, well, maybe here, but then you pass that value via an API to someone else and so on, so it's also not going to work. The solution here may be to introduce a type, right? A monetary value in this example that's from Java. It's not only the value, but it's also got the currency in it. So you can't make a mistake like, oh, I thought this was US dollars. It's not. So think of your API design, think of your code design, like what can I do to avoid such mistakes? When I need to have some implicit information, like here, the implicit information is, oh, I have to know that this is US dollars, whatever, that's bad. Make everything that you have as explicit as possible, like here, giving that. And the second thing, I don't have a slide for that, is, remember I told you the ground, they saw that something is wrong. And they tried to address that, but management didn't listen. And we as leaders with the best connections to management, or we consider us management, sometimes not, and we've had this in other talk, trust your people. They have the best intentions. They want your project to succeed. They want to do the right thing. So just let them. Even if that means, oh yeah, we have this process, but let's bend it a bit, or let's think about how we can change that. Because in the end, it's our job to make sure that everything around the software is working as we want it to work. So for example, have a solid API design and trust your people. So that was example number 1. Example number 2 is the Therac 25 from, I think, the 80s. And the Therac 25 was a radiation treatment device. So someone with cancer and who needs radiation therapy, the Therac 25 was the device who would administer that radiation. And what happened? 3 people died from an overdose of radiation. So the device administered too much radiation on these 3 people. And it took some time to actually show that this is actually a fault. And at some point in time, they found out, oh, this was caused by that device. They found out what happened. But then the manufacturer, after they told them, hey, you have a device that is malfunctioning, that is killing people. No, no, no. We're perfectly sure this device, this machine, this cannot malfunction. Doesn't happen. After it did, after they had the proof, so I really said, no, this cannot happen. I don't know about you, but I've been in some situations, and I've even done that myself, maybe, just say, no, 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 my software, this cannot be the cause. It must be something else, not my software. Well, it did. And what they found out, so what happened? Why did the machine administer too much radiation? There was a race condition when entering the data. So a doctor or a nurse who was just putting in the values for the specific patient, and if certain combinations occurred or if they entered data too quickly, then values were overwritten, race condition, and the amount of radiation was too high. But it took 2 years for the bug to appear. So why 2 years? Imagine you get a new cell phone or you get a new piece of software and you start working with that. So what do? I need to click here, and then, there's the button, there I have to enter the value, and so on. And if you do that over and over again, after 2 years, your muscle memory takes over. You don't have to think, oh, where's the button? You just know, oh, first of all, I have to click right top corner, and then I enter here, and then I press enter, and then I click here. It's automatic. So it just took 2 years for the nurses and for the doctors to get really comfortable with the software of that machine. Then they entered the data really quickly because they knew, okay, the next screen will ask me this and will ask me that. And that, when it happened. So what was the reason? Why did the software fail? One of the reasons is there was one developer, one guy, who wrote the software for this machine. And this guy was also the one who did the QA. So I write the software, and I can say, oh yeah, I did everything right, I checked myself. Yeah, we all know, not the best of ideas. And if something did happen, they got an error message like malfunction 54. This is not the screenshot from the original machine, but this is how I imagine it looks like. Now imagine you have a software and you see this error message. What do? Okay, that's it. Because after that you can just continue. There were no other error messages. You could just click OK, and that's it. So what can we take away from that? How can we save ourselves from doing something like that? The first thing, and I've heard that in another talk here, is be humble and don't dismiss the fact that it might be you. I know from experience that we're super confident in, I'm the best developer. Yeah, he may be on my team, but I'm better. I know what I'm doing. This cannot happen. I checked. I wrote that piece of code. It's not happening because I know what I'm doing. Right? No. My biggest enemy is not my colleague, it's not the other company, this is me. How many times have you had the experience that I have when I look at a piece of code and I thought, what the hell is happening here? Which idiot did write that? Git history, oh, that was me. So, yeah, we have the best intentions, but sometimes more, sometimes less, we make mistakes. So think of that. Think of that like, yeah, well, I'm pretty sure it wasn't me, but I'm going to double check, just to be sure, before I answer something or before I tell someone this cannot happen. Because, I've just said, we as developers, we are biased towards our results. It's a little bit like driving on the street, right? We are the only one, I'm the only one who knows how to drive. Everyone who's going slower than me is just my grandmother, and everyone who's going faster than me is a maniac. I'm the only one who can drive. And I'm the only one who knows how to write software, right? No. It's just a bit of humility. Think about how am I biased? Now, I wrote this piece of code. I want someone else to look at it. I want someone else to have a fresh perspective. And I'm getting to that later. So what is the best way of avoiding that? What I say is, let's have safeguards within our teams. And we as lead engineers or as lead developers, we are the ones who have to make sure that we build these. Because it's not the really cool stuff, right? So as a developer, I want to produce code. I want to write new features, close the next Jira ticket, and so on. But it's our job to make sure that we have these safeguards. And there's a whole variety of things that we can do. It starts by admitting, okay, I may be biased towards what I'm doing. And to educate our people, like, hey, do you really think it's the best idea for you to do this feature all by yourself? Or do you maybe want to have your colleague have a look at it? Have pull requests or code reviews or pair programming or mob programming or whatever you want to call it. Bring people together. Have them check each other. And then have technology in place that helps them with that. Like linchers, like automated tests, like CI pipelines, yada, yada, yada. So we have this whole arsenal of technology, of tools, of frameworks that helps us making, well, maybe not making sure that our software is good, but getting to a better standard. Maybe finding a few of the easy ones so that we can concentrate on working on the hard ones. So have that infrastructure and have that process in place to make sure that people not only know what they are doing, but they also know what is someone else is doing, and that they can be confident in, even if I may have overlooked something, there is a tool or there's a colleague who took a look at it and who can make sure that this bug or this defect actually gets detected. Remember malfunction 54? Don't show error messages. So there are talks, there are conferences about user experience, and this is really bad user experience. So have a better user experience. Don't have this. So this is also an error message that signalizes or that transfers the same idea, but that is way, way, way better. So that gives the user an idea of what actually happened, and that gives him options, or that shows her what do you actually want to do. And there is an exit, like if you don't know what to do, there's a phone number that you can call. So as leaders, think you may not be the best user experience designer. I certainly am not, but bring in these guys or girls who are actually good at that and who can help you make better software in depth. So the next example, I think you have to speed up a little bit, is the Microsoft Zune. Who knows about the Microsoft Zune? Who knows what? Oh, a lot of hands. Who actually had one? A couple of hands. This was Microsoft's reaction to the iPod. So it was an MP3 player by Microsoft, and I've heard that it was actually pretty good. So, but what happened with the Microsoft Zune on the 31st of December 2008? Nothing. Well, people got their Zune out and wanted to play music, but nothing happened. So, 31st of December, what could that be? Edge case in date handling. So 2008, what was 2008? What was so special about 2008? It was a leap year. So this is the code from the Microsoft Zune. I pulled that off the internet that actually run. Horrible code if you ask me. Date handling, oh my god. So let's go through this a bit. Couple of checks, okay. So there is some handling of edge cases, yeah, right? But in 2008, the number of days was actually 336. So this is the code that was running. It was an endless loop until your battery was empty and the device simply shut off. And Microsoft said, yeah, well, we know how to fix this. Just wait one day, tomorrow it will be back on. So that was 2008. 4 years later, in 2012, the Zune wasn't relevant anymore. So that problem solved itself. But iOS wasn't that much better. So 1st of January 2012, the iOS alarm clock didn't work. So yeah, people wanted to wake up, it didn't work. So what was happened there? The week-based year. If you go through that rabbit hole of date formatting and so on, this is what you'll find. This is the calendar for January of 2012. And what you see is that January 1st of 2012 is actually in the calendar week 52 of 2011. Because the numbering of calendar weeks works like the first week of a year is the week with a Thursday in it. So the January 1st here is in the week of the previous year. And depending on which tool, which date format you're using, you get the year, so the real year, or the week-based year. And this is where I always am. So, okay, I have this DM, is it a big D, is it a big M? I don't know. So this is what happened here. And we've got another one, a Lockheed F-22 Raptor. If you remember Lockheed, they were the company with the Imperial units. So we're getting back to that. Super new fighter jet from the Americans. And what happened there? They were transferring that fighter jet from Hawaii to Japan, and in the middle of the Pacific Ocean, everything crashed. So the whole system crashed. Nothing worked anymore. And you can imagine big fighter jet not working without software. So somehow they managed to get back on. They had the tankers in there, and the tankers needed to fly ahead of the fighters to show them the way. And now imagine the cool fighter jock, yeah, Tom Cruise and so on, having to fly behind one of these big tankers to show them the way. So what happened? This is the route that they were flying. Nothing in there, right? Well, there is one thing. There is the International Date Terminator. And once they flew over that, everything crashed. So what can we take away from these three examples? The Zune, iOS, and the Raptor is that date and time handling is complex. It's super complex. There are edge cases over edge cases over edge cases over edge cases. So what you should do is use libraries, use frameworks, use the tools that your software gives you. They abstract that whole mess. It's a mess of date handling and time handling and so on. So just trust them to do their job. And again, for us as architects, as lead devs, if your people start like, oh, well, I can implement that myself, no. Just no. And the last example that I have is something that started in 2020. As far as I know, the bug is still active, which is the Boeing 787 Dreamliner has to be rebooted every 51 days. Why? Because this is what Boeing wrote. Historical data accumulates in memory and might lead to display of misleading data. Historical data accumulates, right? So I imagine they're writing some logs or some metrics or whatever, and they don't clean up after themselves. They just, oh yeah, let's just write that. And once you do the reboot, everything starts from zero again, and you can continue in there. So, lesson to learn, for me, pretty simple, clean up after yourself. It's not like that we have infinite resources. It may feel like that, right? Memory, disk, whatever, we have a lot of it, but it's not endless. So, I hope you had a good laugh. I had the impression that you did. And I also hope that you take something away from just looking at the big guys who are in the spotlight, and then think about, okay, what can we take away from us, from these big guys, so that we are not going to be in the spotlight the next time. Plus, the last thing that I want you to take away is, if you go on vacation the next time, and you happen to find yourself entering a 787 Dreamliner, just make a quick detour to the cockpit, knock on the door and say, have you rebooted that plane yet? If not, now would be a good time. So, thank you very much.